Hello students, today we are going to discuss about a semiconductor device which is a diode. As we have already discussed about PN junction, today we are going to learn about the application where we are using PN junction and what we are doing with the PN junction. So we are starting with diode. Diode is nothing but it's basically a semiconductor device which is having a metallic contact. For what this metallic contacts is, it's for nothing but to give them external voltage. Okay, so it's a two-terminal device. It's a two-terminal device with metallic contacts at the end. With metallic contacts at both the ends. Okay, at both the ends. So we have already learned for what these metallic contacts are there for at both the ends. It is just to apply the external voltage. So now let's see how we can represent or how a diode will be seen diagrammatically. A diode will be looking like this. So now by taking this diode or by having this diode, we can bias it in two ways. A diode can be biased in forward as well as reverse manner. So let's first understand when we are connecting PN junction in forward bias. Forward bias. So what is forward bias? It's nothing but when the P terminal of the PN junction diode is connected with the positive terminal and the N terminal is connected with the negative end of the external supply. So which means if this is the diode and if the P terminal is connected with the positive terminal of the external device which we are using to give the applied voltage, and if the N terminal is connected with the negative, then we can say that the PN junction diode is in forward bias. So when it is in forward bias, we have already learned about the formation and how this depletion layer occurs and all, right? So when the PN junction diode is in forward bias, what will be happening? The applied voltage is in the opposite direction of flow of current as that of the depletion layer. In depletion layer already there will be a inbuilt current because of the diffusion, because of the drift of current, right? So because of this, when we are applying a external voltage, that external voltage will be in the opposite direction. So what will happen? The width of the depletion layer will becoming decreasing. As the width of the depletion layer is getting decreased, there will be more conductivity. So that is how we are making use of a PN junction diode in forward bias. And what will happen in negative or in reverse bias? When PN junction diode is connected in a reverse bias, let's see PN junction in reverse bias. PN junction in reverse bias. So let's say this is a diode. If the P terminal is connected with the negative end of the external source and the N terminal is connected with the positive terminal of the external source, then we can say that the PN junction diode is in reverse bias. So the inbuilt current as well as the external applied voltage which we are giving will be in the same direction. As it is in the same direction, the width of the depletion layer will be getting increased. So this is how we are making use of a semiconductor diode. And we can connect the semiconductor diode or diode in two manners, that is in reverse bias as well as in forward bias. So basically diode is nothing but it's a two-terminal device with the metallic contacts at both the ends. And as I have already told, both the ends are of metallic. It's just because to provide or to give the external voltage.